This is Jason McIntosh with Macintosh Applied Engineering. I'm going to show you how to copy impedance data out of a model using a graph element. Before we do that, I need to spend a little bit of time talking about how Aries handles impedance. This is the icon for a moving coil speaker. It has acoustical nodes with the blue background and electrical nodes with the white background. When you solve a model, Aries solves for the pressure and velocity at each acoustical node and the voltage and current at each electrical node. However, it defines velocity and current as being into the node. It's always defined to be into that node. Then the impedance is defined to be the voltage and current ratio at that node, or the pressure and volume velocity ratio at that node. If this node is supplying power to the load, the velocity will actually be negative. It will be flowing out of that node, which means the impedance that Aries is going to calculate is going to have a negative quantity than what you're probably going to want to see. So we need to keep this in mind when we interpret the impedance data that we're going to see in the model. So I'm going to go back to Aries, and I'm going to open an existing model. This is the model of a simple earbud headset. I'm going to export the impedance data that the rear of the speaker sees driving these three elements. To do that, I'm going to create a graph element and connect it to this rear node. If I connected it to the volume node, I would only see the impedance seen looking into that volume. The pressure and velocity at the volume node is dictated by the volume's impedance. And so their ratio will be determined by the impedance of the volume. The same thing occurs at these port nodes. You only see the impedance into those ports. To see the impedance at all three of these in parallel, you have to connect the graph to a node that is driving all three of these simultaneously. In this case, that's the rear of the speaker. I'm going to create a graph element, and I'm going to connect it to the rear of the speaker. I'm going to move the graph element into our viewing area. And one of the first things I'm going to do is I'm going to have it plot a thicker line for us. I'm going to go to set buffer, and I'm going to change the weight to 3. So now our line is a little thicker here. By default, Aries plots pressure or voltage. So we want to change that to impedance. I'm going to go to quantity and select impedance. And I want to plot the real and imaginary as well. So I'm going to go to advanced options, and I'm going to select it to plot real and imaginary. And I'm going to change the magnitude to be shown in the linear units, not dB. So now let's go back to our plot. So here's the impedance in acoustical ohms. This is the magnitude of the impedance. Here's the real and imaginary part. The real is solid blue line. And you can see that the real part is negative. That means that the rear of the speaker is supplying power into the load. So we would probably like to see the negative of this plotted. You can do that in the graph by going to the advanced options, and under this row here where it says plot using kinetic value, the kinetic value is going to be the current or the velocity. We can switch that value for this particular buffer, the current connector buffer, by just checking marking there. So I'm going to hit OK, go back to the graph. And now we have a positive real part. So now let's go ahead and export this data. One thing I'd like to point out is that when you export the data, it doesn't matter what you have the graph element showing. If you've changed the kinetic value to negative, that won't show up on the data that gets exported. So we're going to go back to Aries. We're going to go to the graph element and select advanced options. In this dialog box, there's an edit menu. The first item is copy buffer to clipboard. You've got the option to hold the control key down for a Matlab format. Otherwise, it's going to be a tab delimited format that's good for Excel. I'm not going to hold the control key down. I'm just going to copy the current buffer using the tab limited format. I'm going to open an Excel window and paste the data in. You get 5 columns. The first column is frequency in hertz. The next 2 columns are the magnitude of the pressure and the magnitude of the volume velocity. And the last 2 columns are the real and imaginary parts of the impedance. If you notice, the real part is negative, so our plotting options of changing the kinetic value to a negative did not affect the data that was exported. Next, I'm going to go back to Aries, and I'm going to export the data in Matlab format. I'm going to go back to the Edit menu, select the current buffer, but now I'm going to hold the Control key down as I click on the menu item. That should have copied the data into the clipboard in Matlab format. I'm going to pull up a Matlab window, and I'm going to paste our data in. This pastes the data in a text format, creating a structure called data. That data structure has a field for frequency, pressure, velocity, and impedance. Notice that when we export it to Matlab, the pressure and the velocity were exported in complex values. So when you export the Matlab, you'll get the complex value for the pressure and the velocity, not their magnitudes. So you get a little more information when you export to Excel. And the impedance is also complex. So I'm going to go ahead and plot this. I'm going to plot the frequency against, I'm going to plot the magnitude of the impedance. Here's the graph that was created. I'm going to pull up the Aries graph as well. And here's the magnitude of the impedance in Aries. And here's the magnitude of the impedance in Matlab that we just exported. And you can see that it's the same data. Okay, so we exported the data, looking into these 3 elements in parallel. If we wanted to export the electrical data, we could do the same thing by putting the graph connector on the electrical terminal. So thank you for your time. If you have any questions, please feel free to reach out to us at support@maellc.com.